I think a challenge for everybody right now is to find a way to how do you actually manage to automate because it's going to be an absolute need. And that's our challenge too. We think like 1 or 2% actually knows about these things. We got 98% that doesn't.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. What engineer doesn't love robotic automation? There's just something about that beautiful combination of software, electronics, and mechanics all working together side by side to complete a task faster and better than a human could, or even doing something a human simply can't do. Robots are an amazing feat of engineering, and today we're going to sit down with an industry leader, Kim Povlsen, President and CEO of Universal Robots, to talk about the state of robotics today and where collaborative robots, or Cobots, fit into the overall engineering landscape. Kim, thanks for being here.
Thanks for having me.
So who is Universal Robots, and what do you all get excited about?
So Universal Robots, we create what you can call collaborative robots. And I'm a huge robot geek myself. I'm probably a geek in general. But if you're a geek, robots are usually pretty cool anyway. And we're building these collaborative robots that are safe to be around, right? We have this grand vision of building a world where people work with robots instead of like robots. So being in a company that kind of tries to change the world through really cool technology, that's what Universal Robots is.
How did you discover your passion for robotics and what got you into them?
So my old dad was an electrical engineer, or he's retired now, but he was an electrical engineer. And you know the 70s, 80s type of electrical engineers, the guys that has their rooms are just full of stuff, electronics everywhere, from floor to ceiling, always building something, not necessarily knowing what he was building, but building something. And I was a young kid, I got kind of drawn into that. Well, that was amazing because he always told me you can build anything. Just look at all these things. I had no idea what it was. But that's, I think my passion started back then for this type of technology. And then, later on when it had to get real, what do I want to do with my life? I was thinking, what is really cool within this type of technology? And well, here you go, robots, of course. But back then it was the movies. You saw the movies with robots. They all had, they all had heads and faces. It makes no sense in real life, I think. But that's how it was. But I thought it was a cool thing. So why not jump into that? So that's where it started, I think.
So did you go right to hardware, or was there a kind of a different path you took to get into robotics?
Since I got interested in technology through, my dad's workshop and those kind of things, I was also a vivid gamer at the time. And you didn't have a lot of choice back then to what you want to game. It's not like today you have, several different types of machine you can buy and you can play whatever you want. Wasn't the case at the time. So I remember I had this soccer game I loved to play, and I found a bug in it so you could score goals whenever you wanted, and it annoyed the heck out of me. It was super annoying. So I decided it's probably time for me to get into programming because I'm going to make an amazing, much better soccer game. I was 12 or 13. So I started, again, back to the geek, right? I started leasing or renting books at the library about programming, and I thought I could build this new fancy program. And I totally failed, of course. I didn't even manage to draw a field or anything, but I thought it was great. So anyway, I kind of knew I was destined to do something within engineering. And that started already back at that age. So I think that's what really inspired me. I always been inspired by the fact that you can take existing things, and if you know a little bit about technology and what you want yourself, or also a little bit what others want, perhaps, you can make much better products, like much better products. So I think that's what got me into this whole game to begin with.
Have you been doing robots since school, or what did you do out of school?
So I'm a robotics engineer. I studied in Odense, where Universal Robots started. Actually, I went in the same school you had the founders playing around with robots when I was like a few years from graduating. They were already building the first one at the school. And I do remember these guys. We all knew they were very smart. We didn't know what they were working on. But back at the time I was done, or when I was graduated out of school, there wasn't that much to do if you wanted to do robotics, except if you wanted to build your own startup. Basically, it wasn't especially in Denmark, there wasn't much to do. So we were like, the city was pumping out robotics engineers and we were all super excited about robotics, but there wasn't that much robotics to go do actually for all of us. So we all ended up in different places, in different industries.
That sounds like a pretty unique situation. Where did that culture come from?
Oh, I think it goes way back actually. Back in here in Odense, which is a I think in US terms a pretty small city. I think there's about 200,000 people living here. It's the third biggest city in Denmark. It's on an island surrounded by water, but it's still an interesting city in respect to innovation. Right back in the 60s, this was one of the birthplaces of the containerized shipment that is now used as the prime way of moving things around the world. So it was a very innovative thing that happened back then when we actually was part of inventing that whole thing. And I think it's kind of interesting because it's this story of a circular innovation thing happening. Because back in the days when the containerized shipping was born, it also enabled the world to ship things around almost for free, you could say, compared to what you were used to. That really changed the way the world was producing things at the time, because suddenly you could start considering outsourcing. Right, it happened a lot to the Far East, for example, where you had lower cost of labor. You had very, very big production sites because suddenly you could send things around the world at practically no cost. And in the 80s, in the exact same places in the world, the Far East, they were starting to be able to build ships at a much lower cost also. So the shipyard had to come up with new ideas. So they actually started thinking about robotics to help build their ships, especially some of the very difficult tasks like welding.
Interesting.
So they came up with some really cool innovations to do welding inside the ship's hull in order to compete. Now, eventually they didn't succeed. It wasn't enough, but it actually ended up starting the technical faculty at the local university, which then turned into the robotics, because there was a lot of smart people who suddenly knew a lot about robotics. And that's how the whole kind of city became slowly a robotic city, you could say. It's really one of the centerpieces of the world today, I believe, in respect to robotics. I think we got more than 100 companies just around here working with the robotics every day.
I had no idea. That's really cool.
Yeah, that's a cool place.
So it's almost an accidental discovery of a robotics technology where it was designed around ships, but then it turned into its own thing.
It turned into its own thing. And also, I think, we're back to the point where we're probably going to change the way the world produces things again. Because suddenly you can do it closer to where you live, or you can do it closer to the actual customer. You don't have to have mega factories across the world anymore. You can do much more closer to where you live. And I think that's kind of a cool circular thing.
Yeah.
Started the journey of moving things far away, get everything produced in one place and then shipped around the world. I think we're back to a place now through new innovation where we can produce things close to home.
I really want to ask you more about that, but before we get too deep into it, I'm curious about something. You spent over a decade at Schneider before moving to Universal Robots. Did you work much with embedded IoT? What did you work on there, and did it relate to your robotics work now?
I was working a lot with embedded IoT in kind of you can call it the infancy of embedded IoT, where I think we could all see the great potential of connecting devices in general, collecting the data, sifting through that data, both through, statistic approaches, but also through, later on machine learning or kind of neural network approaches, trying to understand the behaviors of the devices working with customers. So you could learn how you could actually create better experiences for customers by understanding how they were using the devices you sold them. Back in the energy sector, things like having thermal sensors in rooms, let's say in office buildings, along with the thermostats, you could start capturing that data, understanding when are people actually in the room, when are people actually in the building. There's a seasonality, maybe weekly, maybe monthly, maybe yearly. And then you can start controlling your AC based on that. Today, it's kind of normal. 15 years ago, it wasn't. But if you understand these kind of things, you can save immense amount of power just by knowing how the building actually works and who's in it and when. So I think we could all see the promise of embedded IoT at the time, because if you want to have these kind of cloud-based solutions, well, first thing you need to do, got to collect all that data. And how do you collect that data? And back then, it was a little bit more tricky than it is today. Today, you have, Bluetooth internally, or Wi-Fi, you have LTE mobile, you have 5G coming, so you can connect anything today for a very low price. Back then, it was a pain in the neck to connect anything, I would say. So I think the same premise goes for pretty much every type of product you're building that any customer is more or less directly interacting with. So that goes for energy management. It absolutely goes for robotics too, because it's a part of your daily life, your daily operations. So knowing how they are working, especially if you have more than one, knowing how they're actually working, interacting, looking at that data, understanding how you can make the customer's life better by optimizing something, by predicting failure. It could be all the usual things you always talk about when you connect products. I think that actually goes across anything. Like your car is by all means probably connected today, and it will tell you when you need to go to service. So I think we're just entering an age where we're crossing the barrier of being afraid that things are connected towards the value of connecting is probably bigger than the worry we have of connecting things.
Ooh, that's a tricky balance between risk and reward for sure. Has the adoption of IoT been faster or slower than you thought it would be?
I do remember back in 2015 or so, we all talked about these billion of devices being connected by 2020. And I think, I remember we created all these amazing presentations that we talked about it with the press. At the same time, everybody was like, yeah, it sounds really great, but it is probably not going to happen.
Huh.
But then reality came, and 5 years later, we realized that it was 2 or 3 times as many as the fancy presentations we put at the time. So it went way faster than I thought, and it also happened based on all the surrounding technologies becoming better. Suddenly, you can buy a microchip with connectivity inside. Is all you have to do, right? It became very easy, and you have all these community-based type of development kits you can get anywhere, and they offer connectivity. So suddenly, it became very, very easy and cheap to connect things. So I think it went faster than anticipated. I think it probably than anyone anticipated, I would assume.
Just throw an ESP32 in there and you're good to go, right?
You're good to go.
Well, Kim, it's time for a short break. We'll be right back. This episode is sponsored by EBV's podcast, Passion for Technology. Ready for the next level of optimizing your ears? Techies rejoice! The new Passion for Technology podcast is dedicated to the latest technologies, trends, and applications in the electronics industry, such as a series on analog and power management. There are already 3 episodes out and 3 more on their way. Also check out their recent episodes on silicon carbide and gallium nitride, wearables, EV charging, UV LEDs, edge computing, and, robotics. Tune in now and dive into the world of semiconductors. Subscribe now to the Passion for Technology podcast, available in your favorite podcast tool. And we are back with Kim Povlsen, President and CEO of Universal Robots. Kim, I love tech origin stories. How did Universal Robots come to be?
It was the 3 founders. They were working on a European project to do an automation cell for something. And they were at the university. So you always have to try to work with cutting edge technology when you're at universities, right? Which is great. And they were to build this automation cell, and the choice at the time was, of course, to work with industrial robots. So they got an industrial robots, also 1 or 2 industrial robots, and they were stunned by the complexity of getting this thing up and running. It was really hard to install physically because you have to bolt it into the floor. So they had to change a lot of things around the office space to even get it going. And then actually getting it up and running. And the programming was really, really difficult. So it was really them saying, this is a pain in the neck. This is unbearable. We got to be able to do something better, right? We're engineers. We're right out of school. We're really smart, as they said. We're going to come up with something that is smarter. So we want to build something that is, 1, lightweight, 2, safe to be around. So that's where the collaborative comes in. Extremely easy to install and fun to program. We wanted to change that entire paradigm of how to program robots into something that pretty much anyone can do with just minimum training. So they set out to do that. And well, a couple of years later, they founded UR.
Can you unpack the design challenges and maybe the innovation opportunities involved with cobots? In my head, they seem simultaneously super complicated, but also like super simple. It's just a bunch of stepper motors.
But let me start with, isn't that the magic of really cool user experience type products? You take your latest smartphone. The complexity of those are immense. But the companies who build them, they manage to put all that complexity inside. So you as a user, it's a smooth and beautiful experience to use these products. It's the same with the universal robots that we built. There's hundreds of thousands of engineering hours into making those, to your point, motors and gears just work perfectly, and all the programming around each of these. Because one, they gotta be very robust, right? This is a lightweight type robot, so a lot of it is built in aluminum, which is very lightweight and very difficult to work with and actually create robots off. Because one, you want to create a lightweight robot, and as soon as you have things like aluminum, it's kind of hard to manage. So figuring out how to manage that through both, mechanical design, but also how the motors and gears are actually working in conjunction with the materials chosen. Very complex stuff. That being one thing, and then the notion of being collaborative. So if you touch it or if you get close to it, those kind of things, right? You are able to stop the robot at any time. It has to be always safe. You have to be right next to it, and if it hits you, it stops right immediately.
Okay.
So building that into the robot also, that's also a little bit of a challenge, right? So I think it's all those layers of trying to come up with something that is really robust, high quality. The lighter, the better, because you want people to be able to move them and put them somewhere else, and you need to be able to bolt them or just put them on a desk. It's fine.
Yeah.
Because it can't be very heavy if you want to do things like that. So those are the kind of challenging things to actually make work, and that's what we're continuously, of course, fine tuning. And we got hundreds of engineers working on fine tuning those pieces every single day, because there's always something you can make a little bit better, a little bit less vibration. We have some cool stuff like like in your modern earphones, you got what's it called, sound
like sound cancellation.
Yeah, exactly, right. So noise cancellation, right. So our engineers came up with vibration cancellation, because you know how the robot is going to move, but you can predict that, so you can do, you can do the opposite in the gears, so they actually cancel any level of vibration. So I think that's the next thing. It's also about, if these kind of robots needs to be extremely precise, otherwise you cannot use them in an industrial setting. It just doesn't cut it. If you have 1 centimeter slack, you won't be able to pick up stuff appropriately. I put them inside a CNC truck or whatever you need to do.
Sure.
So it needs to be very precise. And then I think the last thing that is really key is back to how do you make this Cobot work? How do you program it? How do it work with other things? Because a robot arm by itself is kind of like an arm without a hand. So it needs to interface perfectly with a bunch of different type of hands, dispensers, grippers, sanders, grinders, could be anything. So you need to make that interface super simple, both from a mechanical perspective, but also how do you program this one, right? It needs to be super easy. So this is also a big undertaking to continuously figure out how do we make that easier, work with customers, user testing. How can we continuously make this something that a 10-year-old can do?
That sounds really good to me. Easier the better, for sure. You mentioned moving it around. Can you help me understand the difference between a standard industrial robot that you might see in a factory and a cobot?
So collaborative robot, let me see. It's an extremely adverse, right? High quality, depending on the brand, I would say. Very safe, simple to acquire, install, and it should take basically no training to make it work. To do at least simple tasks. Of course, you can do very complex tasks, but at least simple tasks you should be able to do in minutes. That for me is a Cobot. And again, the differences to traditional industrial robots is really the time you spend at setting it up. It's the expertise you need to program it. It's a big difference there. It's the thing where with most industrial robots, you buy it for one thing forever. Right, which they're great at, by the way. It's an amazing product if you want to do. Also, if you want to do something really quick, they're super fast industrial robots. But it's rare. It's rarely seen that you move it around to a different type of application. So it's less versatile. And that's what the cobots are also meant for. You can use it here for a week or a month or a year, and then you can move it to do a different kind of task pretty easily. There's also things about the space requirements. The cobots are actually built to jump into a brown space, meaning it's an existing production that you can put a robot into when you realize you need automation. You don't have to build the whole production floor around the robots, which is normally done when you have a lot of industrial robots. And again, it doesn't need a fence. There's no safety fence around the cobots because they're collaborative. So I think that's the main differences between the two. And frankly, it's not, the answer is by no means always cobots. By no means. It's really for what you're needing.
So Universal Robots has shipped tens of thousands of these by now. Are there any applications that or uses that just really surprise you and the team?
Yeah, I think. So I've been here for a year, a little bit more than a year now, and I get surprised monthly when we see some application pop up where we're all thinking, oh, yeah, that's a pretty good idea. We never thought of that. I'll give you a few examples, but I think that's the cool thing about the way Universal Robots has managed to not just create a robot, but create a platform. Because the robot is API first in pretty much everything. So you can interface whatever you want in any way you want. But that also has driven a significant amount of super smart engineers outside of the company that build their own companies, using the robot, because we're really good at making robots. They might be really good at welding. They might be really good at putting things on a pallet or things into a box. Or, I've even seen, picking out the right eggs from a farm. You see all kinds of stuff all the time. This is where people's ingenuity, it gets into play, because again, we deliver the platform. They come up with the really cool applications. But one thing we've seen in the last couple of years that I think is quite interesting is welding. Welding is a cool one. There is a big labor shortage in welding across the world, the US especially. It's very hard to find welders because it's a craft. You need to be well trained. And sometimes welders have to do very complex tasks, and sometimes it's just the same thing that has to be welded again and again. And a couple of years ago, a number of companies in Europe and US especially, they figured out that they can build like an entire welding cell. So they buy the robot of us. We work with them to help them get going. And they build like an entire welding cell that with pretty much no programming at all. You just show the machine where to weld, and it does it perfectly every single time. That's pretty well done, I think. These guys are smart, right? And their businesses are growing super fast. And because suddenly you can weld anything and you don't have to be an expert anymore.
Sure.
Because they are the experts. That's a cool one.
Yeah.
Another one I like is we start to see the collaborative robots join the construction industry, which I didn't think would happen, but it happened. At least not right now, but it's starting to happen.
I assume that's beyond like hand me a 6mm wrench. They're actually doing the building?
That's a bit advanced. No, they're doing some of the things that people don't really necessarily want to do.
Okay.
And a couple of cool applications I've seen is overhead drilling is a big one. I don't know if you ever tried to do overhead drilling at home. You know how tired you get in your shoulders.
Yeah.
We're both. I don't know. I guess we're both desk people for the most of the time. It's not necessarily. I'm not super strong, I can tell you. So when I do have to do overhead drilling at home, I'm really, really strained, right? And imagine doing that 8 hours a day, every single day. You're gonna get some injuries soon enough. And so some companies came up with the idea of let's do a robot that can actually drive around, and then with laser precision, they do overhead drilling.
Interesting.
You get no dust in your head anymore. You don't have to do this.
Yeah.
It's simple. And it's one of those things you think, should have come up with that. It's pretty straightforward, right?
Right. I know. You just draw a little X, like drill right here, and it'll go do it.
Exactly. And there's an American company in Silicon Valley. They called they're building robots again on wheels that actually manage to do drywall.
Oh.
So they do the painting and they do the sanding afterwards, and it's more or less automated.
That sounds wonderful.
I don't know if you try to do drywall, but that's
so hard.
Yeah. So it's kind of making its way into construction as well. And I think that's a pretty cool thing because that's where people get injured. There's a lot of injuries in construction in general. And I think there is a way here to prevent some of that from happening.
Well, I'm all for keeping people healthy and safe. Let's take a quick break. We'll be right back. This episode is sponsored by the Exponential Technology Group, part of TTI's family of specialists, who is an expert in all things IoT. XTG's engineering team can literally take an idea from the back of a napkin and produce a full product design, from the proof of concept level to software development to cellular carrier specifications in their in-house RF lab. They have been designing wireless devices for marquee customers since before IoT was even an acronym, and as part of the TTI family, they are attached to one of the largest inventories of electronic components on the planet. The latest information on product lead times and availability is considered throughout the design process, and as soon as your bill of materials is fixed, they can pipeline inventory to support your production ramp. Utilize the support of XTG's engineering team to streamline your next product development project. For more information, visit exponentialgroup.com/EETech. That's spelled XPONENTIAL group.com/EETech. And we're back with Kim Povlsen, President and CEO of Universal Robots. So Kim, what are the types of things that your engineering teams are focusing on? What makes these cobots tick, and what gives you the edge?
So there's a lot to it. I would say, of course, we got a head start because we invented this thing. So that gave us a few extra years to kind of perfect the technology. But one thing I also think, before I get into the mechanical stuff, is I think one of the things that makes the universal product special is that it's a company behind that focus on that one thing only. That's what we do. And it's focused with some key focus areas, which is it needs to be collaborative in any way, right? It needs to be super safe. That's one thing. But it also needs to be built in a way that anyone who want to interface anything to it, they can. It always have to be in front of everything else we do. Safety and collaborative, also in respect to other technologies. And then I would say spending the last 18 years perfecting the design. It's a tricky type of technology to even produce a thing like this because there's so many parts inside. And again, it's a lightweight robot, so you have to manage any type of strain happening in the tubes and across the joints, etc. So managing to do the investment of R&D to continuously have enough kind of power, brute force power around the R&D side to actually continuously just perfect the design. I think that's the key point here because there's several teams just working on the joint every single day. How can we perfect it? How can we move a little bit more vibration? How can we make it stop faster? Right? How can we move a little bit faster while still making sure it's within the safety boundaries that we're setting for ourselves? Having people only focused on that and nothing else, I think that's the key. We're not building any other products. That's what we do. We don't have plans to build any other type of products. This is what we do. So focus, if I had to say one thing, if that makes sense.
No, that makes perfect sense. If one showed up on my doorstep, what would I have to do to make it hand me a cup of coffee?
So there is a community, and there is a whole ecosystem around Universal Robots. It's one of the cooler things that we also invented here. We call it UR Plus. That's the name of it.
Okay.
It's an ecosystem of technology partners that build all types of tech around the Cobot itself. Because again, we only build the Cobot. We don't even build a gripper, not even one. We don't do that. We just focus on the Cobot. Back to the focus, right? But we have, I think, close to 400 different products in the ecosystem. Some are grippers, some are dispensers, some are sanding, grinding. Some are creating entire application, like a palletizing application. If you need to move boxes from here to here, there's an entire application. It's like, I guess IKEA, right? You go and buy the whole thing, and there it is.
Yeah.
And you know how to assemble it by yourself. It's straightforward. Like a 5-page book. You do 8, 1, 2, 3, 4, 5, and you have your application up and running. So having this ecosystem that builds both hardware components, but also software components, and more, I think this is the future, building way more applications so you can kind of plug and play depending on what you need. If you want to have it hand you a cup of coffee, you should go in and find a handing me a cup of coffee type application, and you buy the whole thing, and it's up and running in no time. So, of course, making such an ecosystem, there's a lot of interfaces that needs to be fine-tuned. There's a lot of certification you have to go through if you actually want to sell products that are certified by Universal Robots in order to keep the quality at the right level. But if you just want to do it yourself for kicks, you can totally do that. There's an open API.
So it sounds like there's a lot more to it than just the hardware. There's an entire software and application layer that stands out and makes life easier for users.
Yeah. And I think if you look at our engineering, 70% are software engineers. It might be embedded software and high-level software.
Okay.
Because the main interaction point from anybody who uses the robots is the software, right? You have to do some I/O if you're working with a machine and you want to kind of collaborate with that machine, interact with that machine. You have I/O, so you can program that from our programming interface as well, or you might want to do it from a totally third type interface. That's up to you as a user. So there are some very important electronics and mechanics you have to go through, but in general, the most time to spend with the robot is through our software. So that needs to be super intuitive. It needs to be easy to program. At the same time, it needs to be able to be flexible enough. And that's the very hard part, right? You can make something that is really easy to use, but then it's usually not flexible enough for what you want it to do. Right? That might work on a smartphone, but it doesn't work when you're building a robot application. You need some flexibility to build what you're actually trying to do, right? You can also make something very, very flexible, but then you're back into 1990s type software where you can do everything in the world, but nobody knows how to do anything. It's totally impossible. So the trick, and that we're striving for every single day, and we're busting our heads against, it's really the thing. How do you make it flexible and really easy to use at the same time? And you can decide to make a compromise, but that's not really what we're going for. We're trying to see if we can build the world and do both. Not easy, I would say, but that's kind of what we're shooting for. That's the magic, I think.
Sounds like another tricky balance of overly flexible versus overly usable.
Yeah, and isn't that for anything, any product nowadays? You think?
Yeah.
You think about cars. Some cars are like incredibly intuitive to try now, and some of these great new car manufacturers, they figured it out. While you get into other brands and you have 200 buttons to push, you got to go figure out how to even start this thing. So yeah, it's the whole usability journey. I think it's really key for not just for robots, but for any product in any industry moving forward.
What sort of challenges do engineers commonly face when they're trying to go from no robots to robots and cobots in their facility?
It's a great question. I think the matter of the fact is right now, we believe like 98% of the market, they don't even know about robots. The ones that actually need robots. The challenge we're all facing in the world right now, where the population is aging, but they're living longer, and a lot of people are retiring. That means the demand for production of anything, it actually keeps growing. But the amount of people in working age is decreasing. So you have one option, basically, and that's to automate. So I think a challenge for everybody right now is to find a way to how do you actually manage to automate, because it's going to be an absolute need. And that's our challenge too. We think like 1 or 2% actually knows about these things. We got 98% that doesn't. So for us, again, the mantra we have is when they realize that this is a solution to automate, and if it's the right one for them, our mantra is to take it to a place where it's so easy to do that you can actually do it yourself without having programming skills, without taking classes for a year, without having to bring in months and months of work from experts, because you might not be able to afford it as a company to do so. So I think to your question of what is the barrier? I think there's a lot of, for I would say all the understandable reasons, a little bit of fear of don't know what you don't know, right? These automatic things moving around, how will I ever, as a business owner or running a production, how would I ever make that thing work? And what if it breaks? Who's going to help me? All those kind of things. How do I even manage? And giving these people peace of mind, and hey, this is actually really, really easy. And you can manage the most of it yourself, and here's where you get help. I think that's the biggest challenge for people to actually take the step. But what we also see when people do take the step, they're in. Like, oh, this is super easy. This wasn't it wasn't so hard after all. Making the jump, that's a hard one.
So you said something that really got my attention. You said that 98% of people that could be using these aren't. So what sort of questions should engineers ask themselves to figure out if this is right for what they're doing?
I think there's a lot of amazing opportunity for engineers to figure out how they can help the industry of obviously pretty much every industry that needs to automate. It's a golden opportunity right now for anybody to think, I could build something that makes sense here. Because again, you don't have to build the robot anymore, but the application is what people need. People don't need a robot. If you have I don't know, let me say something. You have a toothpaste company, right? Yeah. And you need some level of automation. You don't need a robot, right? You need a solution to put all of the finished toothpastes into a box and put the box on a pallet, and something to push the pallet into a truck. That's what you need, right? You don't need the robot. So there's a golden opportunity for anybody to think, how can I actually really solve the problems that I come across? Because trust me, any production company you will visit, you will see, when you start thinking about it, you'll see, oh, you could actually automate this thing. And why don't you automate that thing? And this seems cumbersome. Why are you doing that? So I think we're at a point in time, which also talks to the 98%, where probably only a couple of percent of the cool applications that's going to change the world, they're invented. I think we have a lot to see still.
So what is the future then? What does it look like 3 years out, 10 years out, 100 years out?
I think there's a future where the biggest difference from where you see ordinary thinking around robots today, where you see a big hall of robots, they're moving big heavy things and doing big welding and big spot welding, these kind of things. I think that's still going to be around for sure. That's key. But I think you're also going to see a totally different interaction between people and robots. I think you're going to have a natural flow of production. I'm thinking just 5 years out, maybe 10 years out in respect to how many does it. But I think you're going to see a world where, people work side by side with robots. It's kind of like their extra arm, because they also become more intelligent, and whatever you tell it to do, it will do for you. And you will have robots taking care of a lot of the tedious tasks that people frankly find, we use the 3Ds, it's dull, dirty, or dangerous. We often say that, right? So I think that's going to be a world where you don't have to deal with these kind of things. And you as a person, you can take on more fulfilling tasks that you think is more interesting and actually brings more value, because people are creative. People have ideas. Robots do not. At least not yet. And I think there's a long way, if that ever happens, for that to happen, right?
Sure.
But they can do all the stuff you don't want to do. And I think that's going to be a reality pretty soon.
So I'm not going to ask about robots becoming sentient and taking over the world, but what is people's perception? How do they respond when you tell them that you work on robots?
First, it's like, oh, robots? Cool. That's and then they probably think in the back of their minds, wow, you're a real geek. And I'm like, probably. So sure I am. And I think the tides have changed over the last 10 years. I think 10 years ago, people were afraid when they hear about robots, because either you seen very, very big robots moving cars, like just grabbing a car and moving it, right? That's one way you might have seen it. Or you might have seen Terminator, the movie, and you're really afraid of robots because of that. But I think the general awareness and understanding of robots has also really changed over the last 10 years. So the feedback I get now is like, yeah, that could probably be helpful here and here and here, because people are less afraid of them now, because they realize you can get robots that are safe. And they're not that smart, right? They won't do anything you don't tell them to do, so to speak.
For better, for worse.
Yeah. So I think the perception is changing quite a bit. So it's a positive generally, but you still occasionally run into the person that remembers Terminator 2 a little bit too well.
Well, that reminds me, it's time for our last break, but don't go anywhere because, in the words of the Terminator, I'll be back. This podcast is sponsored by Control Automation, all about Circuit's sibling site, which you can find at control.com. We're hosting our first inaugural virtual event, Control Automation Day 2022, on June 21st. That's coming up. Control Automation Days will be PLC themed, who doesn't love a good programmable logic controller, and features keynote speaker Dan DeYoung from Rockwell Automation and Moore's Lobby alum Massimo Bonzi, Arduino co-founder. Sign up now for Control Automation Day by going to www.control.com. You won't want to miss it. And we're back with Kim. Kim, what's the state of government regulations? Is it in a pretty good spot, or is there some work to be done there?
There's actually quite a lot of regulations. They differ from region to region, right? In US, you have certain regulations. In the European Union, we have different ones, and in Asia, different ones again. I think there is actually quite a good amount of regulations already that requires any robotic cell setup that it has to be somewhat certified to make sure it's actually safe. That's the most important. The most important is nobody ever gets hurt in a robotic application. So from my perspective, this has actually been well managed throughout the lifetime of robots. Also because the robotic industry is 60 years old. It's not new. It's just the collaborative ones that are pretty new, you could say. So those things have been regulated relatively well over the years. It's not too much. It's not too little. I think we're in a pretty good shape, pretty good place.
That's encouraging. I want to throw some lightning round questions at you now. If you could have a robot automate any household task for you personally, what would it be?
Absolutely vacuuming. And as a robotic geek, I have to admit I failed implementing one of those. But I think about it every week. Wouldn't it be wonderful to have a robot that did your vacuuming? And it exists, but I don't have one.
Every time you vacuum, it's like, man, where's my robot? It's time.
Exactly.
If you had to replace an appendage with a robotic appendage, which one would it be and why?
Is that like a body part?
Yeah. Go full cyborg.
Yeah. And I had to replace one. I couldn't just add one, because...
Yeah. Or if you could just add one with a third arm, why not?
Yeah, it's a weird thought, but it could be practical sometimes. I think I would add an arm, actually.
Yeah. Where would you put it?
Yeah. Maybe maybe far out on one of the arms, because then you had a really long arm. That could be really useful sometimes.
Oh, interesting. Okay. It just kind of fold out like Inspector Gadget or something.
Exactly. There you got it.
I hear you're a competitive squash player. Have you ever tried to think about making a doubles partner out of a robot?
I think the problem is I know too much about robots to think about that. We're too far away from robots being that good. Okay. And I also know if you had a full-size robots in human size, it would be a little bit heavy. And I don't want to run into one of those, I would say, because that happens from time to time on a squash court.
Okay. I played a lot of racquetball, so I can imagine running around with a robot on the court would not.
Yeah, what do you think about that?
It'd be kind of scary.
Yeah, right?
Yeah. Just in general, the concept of high-powered robotic movement kind of just makes me nervous being around it.
And also I would add, thinking about vision systems and compute power nowadays,
yeah,
they'll probably beat our ass totally.
Oh, yeah.
It will be super fast and super precise.
Yeah.
So that's not good either, right? You don't want to lose.
What is, going a little off book here, what is the perception of kind of like pop culture robots? So like there's the Boston Dynamics dog and then the humanoid robot that always goes viral with them like pushing it around and stuff. What's the general industry perspective of that type of like spectacle?
I actually think everybody likes it. It's hard to imagine, and I think everybody's doing two things. One, they're trying to imagine how can these things be used in real life, right? That's always because a lot of us who are working on kind of industrial robots or in that field, we're trying to always build robots that can be used for a specific purpose. So it's always a question like, how are they going to use, a robot that does, what's it called? You can jump around and.
Oh, like parkour.
Yeah, exactly, right. How you use that in real life, but on the other hand, it's also intriguing to see because they're really pushing the boundaries for what you can do with robotics, right? In order to make that work, us robotic geeks, we know how hard that is.
Yeah.
To make a robot jump around like that and not tripping over all the time, that's incredible achievement. So we're also really intrigued by seeing the pushing of robotic boundaries all the time. So I think that's the two things. So it's generally very positive. I think it's impressive.
That's great. I always love when competitors can have some mutual respect for what each other's doing. Is the industry overall pretty friendly?
I think so. Yeah. Of course, we're at some level competing, but as I also mentioned, we only scratch the surface of the market. So you could even say there's room for all of us. And I would say in UR, we're on a mission to get to that point where people can work side by side with robots perfectly. And if and when and other companies, they come in and come up with cool innovations to help with that mission, that's perfectly fine. That's great, actually.
Well, sadly, we are out of time. Kim Povlsen, President and CEO of Universal Robots, thank you for your time today. This was great.
It was fun talking to you. Thanks a lot for having me.
It was my pleasure. Anytime. So that's it for today. Thank you for joining me in the lobby. I personally can't wait for Cobot technology to make its way into my house and make my life a little easier. Maybe it can do the dishes, which would be life-changing. I do have a quick favor to ask. We've had this going for a few episodes now, but it's not too late for you. Hop on over to the Moore's Lobby social media pages and tag someone that you think would like this podcast. If you do, we have some swag to send you that I think you'll enjoy. And that's it. I'm your host, Daniel Bogdanoff, and I'll catch you next episode.